Welcome to Metrology lecture series. In the present video, we will discuss the measurement of gear tooth thickness by constant chord method. In the previous lecture, we discussed the measurement of gear tooth thickness by gear tooth vernier caliper. In the gear tooth vernier caliper, both the chordal thickness and chordal addendum depend on the number of teeth in the gear. So we know the relation is the chordal thickness is W equal to mt sin 90 divided by t, and chordal addendum small d equal to the m plus mt divided by 2 into 1 minus of cos of 90 minus t. So in the both of the equation, so chordal addendum and chordal thickness both are dependent on the number of teeth. So this means for different gears we must do the separate calculations for the each time. So the process become time consuming and making it complicated. In this regard, the constant chord method removes this difficulty. So next we have to look the what is the constant chord method. In the constant chord method allows to use one single setting for all gears which have the same module and same pressure angle. So in the constant chord method, we are using the only single setting. So which is the suitable for the all the gears, but all the gears should be having the same module and the same pressure angle. So constant chord method does not depend on the number of teeth. Let's see what is the constant chord. Constant chord is a line joining 2 points on opposite sides of a gear tooth. And these points are where the tooth contacts the mating gear. And when the center line of the tooth lies along the line of gear centers. And this chord is usually represented as AB. So the basic idea of the constant chord is the constant chord of a gear is measured at the point where the gear tooth surface touches the basic rack tooth surface. So let's see the how to draw the constant chord. Constant chord is the straight line joining two contact points on opposite sides of a gear tooth when the tooth is in a symmetrical position between the two gears. So in the schematically here I have to observe. So this is here. So this is the symmetric portion when the gear is contacting with the opposite side. So let's see how to draw this constant chord. So this is the schematic representation of the single teeth, and this is the base circle, and this is the pitch circle. So let's see the procedure how to draw the constant chord. So first we have to draw the tangent from the base circle and it intersect the tooth at point A. So in the schematic you have to observe. So this is the base circle. So in the base circle we have to draw the tangent and it will be intersect the tooth at point A. So this point A, it is intersect the tooth. After that we have to draw the horizontal line from point A and it will be intersect the tooth at point B. So this is the point B. The line AB calling as constant chord. So here observe the, so here it is the making angle is pressure angle phi. So similarly here also it will be make the angle pressure angle of the phi. So this is the procedure of the, so draw the constant chord line. So here line AB we are calling as the constant chord. So from the pitch point capital P, draw a horizontal line is called as the pitch line of the rack. So this is the pitch point. So this is we are calling as the pitch point and we are indicating the capital P. So from this point we have to draw a horizontal line. So this is the horizontal line and this line we are calling as the line of the rack. So this is the line of the rack. So here the length of the AB. So AB is the constant chord. The length of the AB and its depth from the top of the tooth can be calculated using the formulas and then checked using the measuring instrument. So here in the schematic you have to observe. So the length AB we are calling as the constant chord. So have to measure this length AB. So moreover we have to determine this length AB. So from the position of this length AB from the top of the gear tooth. So from the top of the gear tooth. So this is the top of the gear tooth. So let's consider AB is length of the AB we are using the capital C and small d is the depth from the top of the tooth. So which is equal to the JC. So JC we are calling as the depth of the, so this chord position we are using the notation is the small d. So small d equal to the JC and length of the chord that is the indicating the AB we are using the notation is capital C. Now we have to determine this C value and D value. Let's see the calculations. So we have to determine the AB that is the capital C and small d that is the JC. So from the figure I have to observe. So this is the D. So D is which is equal to the JC and this JC we can be written as JP minus PC. JP minus PC which is equal to the JC. So from the schematic you have to observe here. So JP, so pitch point to top of the gear tooth we are calling as the addendum and let's consider the PC. This value is, let's consider the small h. Then small d will become the JP minus PC which is equal to the addendum minus PC which is equal to the addendum minus small h. So then D will become the M minus H. So now we have to calculate the H value. So small h which is the PC or CP. Now we have to calculate this CP value. Let's consider the CP value is the H. So for determining this one we have to consider the one right angle triangle here that is the CAP which is the making angle of the pressure angle phi. So here once again you have to redraw here. So this is the right angle triangle. So which is the making angle of the phi at A. So from this right angle triangle we can be write as sin phi equal to the PC divided by PA. We know that one the PC or CP which is equal to the small h. Then sin phi equal to the h divided by PA. So this is h divided by PA. So from this one we can be rewrite as PC or small h which is equal to the PA into sin phi. So now we have to determine the PA value. For determination of the PA value, once again you have to consider the another right angle triangle that is the ADP. So here ADP. So this is the another right angle triangle. So now I have to consider the another right angle triangle to determine the PA value that is right angle triangle. So A, D and P. So this is the right angle triangle. So from this right angle triangle, once again here we have to redraw here. So here making the angle phi. So at D it will become the 90 minus theta. So here angle is the 90 minus theta. So from this right angle triangle we can be rewrite as sin theta, that is sin of 90 minus theta equal to the AP divided by DP. So AP divided by DP. So which is equal to the cos phi equal to the AP divided by DP. So from this one AP equal to the DP into cos phi. So now once again you have to determine this DP value. So for this one I have to observe here. So DP, the amount of DP which is equal to the arc of the PF. So DP equal to the arc of PF. This PF arc value. So this arc PF value is the 1/4 into circular pitch. We know circular pitch equal to the pi into m. Then DP equal to the, so this DP equal to the arc of PF, which is equal to the 1/4 of circular pitch, which is equal to 1/4 into pi into m. Here m is the module. Then so we know that one the PA equal to the DP into cos phi, but DP value is the pi m divided by 4. So substitute this DP value in the PA equation, then PA will become the pi m by 4 into cos phi. So let's go for the first equation, which is H equal to the PA divided by sin phi. So we know that one the small h equal to the PA into sin phi. We know the PA value. Then h will become the PA into sin phi, which is equal to the h equal to pi m by 4 cos phi into sin phi. We know the h value and we know the m value. Then small d value, which is the JC equal to the small d equal to the m minus h, which is equal to m minus pi m by 4 into cos phi into sin phi. So here m have to take the common, then equation will become the small d equal to the m into 1 minus of pi by 4 into cos phi sin phi. So this is the small d. So next we have to determine this AB value. So now we have to determine the AB value, which is we are considering the capital C. So from the figure, AB equal to the 2 times of AC. So AB we can rewrite as 2 times of AC. So for this one I have to consider we have to determine the AC value. For this one I have to consider the one right angle triangle here. So that is the triangle CAP, which is the making the angle theta at A. So from this one cos phi equal to the, so base AC divided by PA. So cos phi equal to the AC divided by PA. Then AC equal to the PA cos phi. Once again we have to determine the PA value. For this one we have to consider the another right angle triangle. So that is the right angle triangle ADP. So another right angle triangle ADP. So from this triangle, so here making the angle phi, here it is the at the D 90 minus phi. From this one sin theta, sin 90 minus phi equal to the AP divided by DP. So which is the cos phi equal to AP divided by DP. Then AP or PA, which is equal to the DP into cos phi. So next we have to determine the DP value. So from the figure, DP which is equal to the arc PF. So we know the arc PF value is the 1 by 4 into circular pitch. Then dp equal to the 1 by 4 into pi m. So we know the dp value, then substitute in PA equation. Then PA equal to the 1 by 4 into pi m cos phi. So we know the PA, then I have to substitute in the AC. Now AC will become the, so PA into cos phi, PA equal to the 1 by 4 pi m cos phi. Then AC equal to the 1 by 4 pi m cos phi into cos phi. This is the cos square phi. Then AC equal to the pi m by 4 cos square phi. So we know the AC. Now AB value is the 2 into AC. Now AB equal to the 2 into AC, that is 2 into 1 by 4 into pi m cos square phi. So from this we can be rewrite as chordal length, that is AB equal to the, we are indicating the C. Then C is the, so constant chordal length. So constant chord C equal to the 1 by 2 into pi m cos square phi. So this is the and D value and the C value. So this is the calculation for the determination of the constant chord and the depth of the constant chord from the top of the tooth. So this is the calculation, and thank you.